6.2 is the law of sines. And so we can read here, it says the process of finding the unknown side lengths and angle measures in a triangle is called solving a triangle. Now, everything that we've done so far always dealt with the right triangle. So we were able to use SOHCAHTOA, we were able to use X, Y, and R. But what if it's not a right triangle? What if it's what they call an oblique triangle? So if not, one of the ways that we can solve this is by using the law of sines. And so you can see here at part 1, it says in any triangle ABC with sides of lengths A, B, and C, we can take sine of angle A over side A, and that's equal to sine of angle B over side B, or it's equal to sine of angle C over side C. And then it says, or equivalently, and so it shows it with it being the reciprocals. So what it's saying there is it doesn't really matter if you put the angles on top and the sides on bottom, or vice versa, it's still going to be equal. Now, this doesn't mean it has to be equal to all three of them, okay? I mean, it will be, but you just only need to use 2 of them in order to help you solve it. So you could do sine of A over side A is equal to sine of B over side B. You could use sine of angle A over side A is equal to sine of angle C over side C. You don't have to use all 3 of them. Okay, so what this is telling us, though, is that the lengths of the sides of the triangle are proportional to the sines of the measures of the angles opposite of them. And so they have a couple cases here. So part 2 talks about solving a triangle by cases. And so what we're going to call case 1 is if we have angle side angle or angle angle sides. Either way, we've got 2 angles and a side that is known. So let's look at example 1. So example 1 says we want to solve triangle ABC with angle A is 62 degrees, side C is 14 feet, and angle B is 74 degrees. Round side lengths to the nearest tenth. Alright, so the first thing I'm going to do here is I'm going to set up my little answer box. It wants me to solve the triangle, so I need all 3 angles and all 3 sides. And I know that once I have this filled in, I'm finished. So that's my answer box. Alright, so I'm going to plug in what they told us. So they told us angle A is 62 degrees. And they told us angle B is 74 degrees. And they told us side C is 14 feet. So what can we find first? Well, in order to use the law of sines, you have to know an angle and the side opposite of it. So that means you have to know angle A and side A, or angle B and side B, or angle C and side C. So if only side I know is side C, so I need to know angle C. Can I find that? I can, because remember, we know that a triangle has 180 degrees in it total. So we're going to take 180 minus the other 2 angles added together. And this gives us 44 degrees. And so you'll notice we don't have a right triangle here. So this is an oblique triangle. Any triangle that's not a right triangle is called oblique. And so we can use our law of sines now to set this up. Now, although we hate to use something we had to find in case we made a mistake, we don't have any other option in this case. So we're going to have to use that angle C. So I'm going to use the formula. I'm going to change colors here. I'm going to use the formula that sine of angle C over side C equals, and let's find side A first. So sine of angle A over side A. So I'm going to plug in what I know. Angle C is 44 degrees. Side C is 14. Angle A is 62 degrees, and we're looking for side A. So we're just going to cross multiply, and then we're going to divide by what's left here. So we have 14 sine, or I'm going to do the other one first. I'm going to do is A times sine of 44 degrees, doesn't really matter, equals 14 sine of 62 degrees. So divide by the sine of 44 degrees. And so we got A is equal to 14 sine of 62 degrees divided by sine of 44 degrees. So let's put this in our calculators. Let's make sure we're in degree mode. round it to the nearest tenth. So it should be 17.8. So side A is 17.8 feet. Now we just need to find side B. Well, you can't use Pythagorean theorem. This is not a right triangle, okay? So we're going to use, I have to use the law of sines again. Now we could use angle A and side A, or we could use angle C and side C. Either way, we had to solve for one of them. I'm going to go ahead and use angle C and side C. One, because I used it on the other, but two, I know that side C was exactly 44, I know angle C was exactly 44 degrees. On side A, we had to round. So if I use my rounded value and then I round, I'm going to be off a little bit more. So I'm going to go ahead and do sine of angle C over side C. And I know that's going to be equal to sine of angle B over side B. So let's plug in what we know. Angle C is 44 degrees, side C is 14. Angle B is 74 degrees, and we're looking for side B. And so once again, we're going to multiply and divide, cross multiply and divide. So divide by that sine of 44 degrees. And guys, remember, if I seem like I'm going too fast, I'm really trying to slow down a little bit because I know I tend to work fast. But you can always pause the video, okay? Pause the video, work a little bit ahead, and then let me catch up to you to see if we did it in the right order. Okay? So we got B is equal to 14 sine of 74 degrees over sine of 44 degrees. So we're going to plug this in our calculator. And we should come out with approximately, rounded to one decimal place, 19.4. So I have 19.4 feet. We've solved all the parts of our triangle, so that was what we were looking for.